Hello there, welcome to section 6 of Unit 2, and in this section, we'll be looking at elasticity. Let's go through the objectives of this section. At the end of this section, we should be able to define stress or strain exerted by a force on a material, explain the different types of stress and strain, differentiate between elastic and plastic deformation, and also define the model of elasticity. Knowing the behavior of a material is very important to scientists and to engineers and industries too. It is very important to know the appropriate material so that you know the correct material to build the structure. For example, like building a bridge beside or by a traffic light. And we know that during traffic, the bridge will be subjected to a lot of loads. So before the bridge is erected, samples of steel are sent to the research lab to undergo some testing. In Ghana here, we have some standard authorities that will send a material that is manufactured in Ghana here to be tested before it can go to consumption. There's one important thing that we use in sciences here that help us in this test, and one is called stress. We can define stress as a measure of the strength of the force that is causing deformation. Mathematically, stress is equal to deforming force over the cross-sectional area, and it has a unit of Newton per meter squared. There are three basic types of stress, and one is the tensile stress, box stress, and a shear stress. We're going through all these types. Let's look at the types of stress. 1. Tensile stress. We can define a tensile stress as a deforming force that stretches the body or material in only one direction, and it has a formula: deforming force over the cross-sectional area. Box stress. This is a type of stress that the deforming force acts uniformly and equally from all sides of the body. Box stress causes the entire body to decrease size, as shown in the direction here. We see how all the forces are applied to. A shear stress. A shear stress is when a deforming force acts tangentially over the area of a body, and this time around it causes the body to get sheared through an angle, say alpha. Such a deformation results in a tangential stress. Now let's look at strain. A strain is a fractional deformation resulting from stress, and a strain has no unit. So for the types of strain, we will first look at tensile strain. Tensile strain is when the deformation force results in a change of length E. Then the tensile strain can be given as the change in length over the original length. Box strain. Box strain is when the deforming force produces a change in volume. And mathematically, we can express the box strain as the change in volume over the original volume. There's a negative there because there has been a change in volume by the deforming force to be smaller as compared to the original volume of the object. Shear strain. Shear strain is a measure by the ratio of the relative displacement of one plane to its distance from a fixed plane. In modulus of elasticity, we can define three terms here. That's one, the Young's modulus, the bulk modulus, and the shear modulus. Let's first define the modulus of elasticity, which is always defined as what? The shear over the strain. We already know the types of strains and stress we have. So let's look at Young's modulus. We can say that Young's modulus is equal to what? Tensile stress over what? Tensile strain. And we already know the formula for tensile stress as what? F over A. And tensile strain as what? E over L. We divide and we get a final expression as FL over AE. Likewise for the bulk modulus, that's the bulk stress over bulk strain. We already know the formula, you put it in, you get a final expression as this. The same for the shear stress over shear strain. So don't confuse yourself with any of this. Just know that for Young modulus, we have stress over what? Strain. Hooke's law. So Hooke's law states that stress is directly proportional to what? To strain. And from our diagram here, we can see that it's proportional to a particular point here, where we call the proportionality limit. At this point, when it exceeds the point, it deforms. but after deformation, it comes to its original state again, unless it reaches a point here called what? The elastic limit, where after deformation, it doesn't get to its original state again.